The foil swing generator. Air, fire, earth and water. These are the four elements of our wonderful globe. Since the beginning of mankind, we have collected energy from all these elements. As the world's population grows to over 7 billion people, the need for clean, efficient energy is prominent. Carbon emissions from non-renewable energy sources are high-priority items on political agendas, prompting governments and businesses to invest more to find new renewable sources of energy. The wind, the sun, and water are the basis for producing new energy, as these elements are constant and renewable. Hydropower from river-based power plants, solar cells and wind turbines are the most common and effective sources of green energy today. Scientists, inventors and bright minds around the world are constantly working on how to extract energy from new sources. Technology is being deployed to capture the energy from ocean tides and waves. The Gulf Stream alone contains energy equivalent to 50 times all the rivers on the planet. The UN Climate Panel points out in their report of June 2011 that ocean currents may be the most promising source of energy for the future, but new technology is needed to tap this resource. A small but successful company in Kristiansand, Norway, Coriolis is developing a new technology for extracting tidal energy. Coriolis' partner and managing director, Engervik, is an enthusiastic windsurfer, electro-engineer and inventor. It was his knowledge of nature, the wind, ocean and current that first gave him the idea of the foil swing generator. This is where the idea sprung to mind.
One day I was out windsurfing. I was supposed to tack up this fjord and meet my friends on the other side. But this day I have problems doing that. And that was because of the ocean currents. And the ocean current was acting on a very small keel on this board. But it was very strong and it was out forcing the forces of the sail. And I was starting thinking that okay, we can use a foil technology to harvest energy from ocean currents. And also as a diver, I knew when you are submerging air into water, you'll get air pressure. And air pressure is energy. It's stored energy. You can use it to anything. And by combining a hydrofoil and air pressure, you have a concept of making the foil swing generator.
This concept was worth taking to the next step, as air itself is a source of energy, and when compressed, it contains a powerful force. Examples of this are the classic water bottle rocket and the industrial strength power tools. Engervik contacted several institutions and individuals to help develop the theory. One of the challenges was to find the best way of controlling the foil in the ocean current. To help address this question, one of the world's leading experts, Professor Konstantin Matveev at Washington State University, was approached.
My name is Konstantin Matveev. I'm an assistant professor at Washington State University. I'm currently involved in studies on the foil swing generator. We conducted numerical calculations on hydrodynamics and energy conversion of this device and found that significant useful energy can be generated with a simple hydrofoil that compresses air by submersion in water. The foil swing generator can become commercially viable if initial cost and maintenance of this system will prove to be much smaller than those of turbines, or if the compressed air is a main required output rather than electricity. The foil swing generator can be also superior to conventional turbines in conditions unfavorable for turbine operation or installation. For example, this technology can successfully operate in slow ocean currents with velocities 1 or 2 meters per second, or in locations with large water depths. Actually, the performance of this system increases with larger submergence, while it's more difficult and costly to maintain turbines in such conditions. I think that the foil swing generator is a significant innovation in the renewable energy industry and represents technology promising for future studies.
The mathematics and economics behind the idea seemed right. So in 2008, Mr. Engervik and Coriolis had the idea patented. The following computer simulation was also promising. The hydrodynamic foil, containing air in compartments, is submerged by the lift force from an ocean river or tidal current. While the foil starts to submerge, the hydrostatic pressure compresses the air in the air compartments. When the foil reaches a suitable level of submergence, the air compartments are locked and the foil starts to rise. The air contained in the volume is kept compressed until it reaches the upper turning point, where the air is offloaded. The compressed air can also be offloaded at the lower turning point. This motion is considered as one cycle, and repeated cycles of this maneuver will continually provide compressed air. The compressed air can run a turbine for the production of electricity. The foil will be anchored upstream with lines. These lines will give two additional vertical forces: a cross-flow drag force and an axial force due to the angle between the seabed and line. The compressed air can be fed to shore or to a platform where it could run a turbine for the production of electricity. We constructed a small-scale foil in cooperation with the research laboratory at NTNU and Marintech in Trondheim. We conducted live experiments as part of a master thesis. The ship model tank at Marintech was used for the test, where we studied the stability and movement of the foil. We found that the control mechanism worked. The foil was stable in relation to stall and yaw and could easily be maneuvered up and down in the water column. The results were stored as a time series, interpreted and then processed for comparison with results from the numerical model. The answers we got were again promising. Our theory seemed to work in our in-water test environment.
I am Professor Sverre Steen from NTNU in Trondheim. In 2011, I was supervising a master thesis studying the Coriolis technology. This technology is based on exploitation of the energy in ocean currents by means of a foil, which is moving vertically up and down in the current, generating energy in terms of compressed air. The model tests that we performed here in the towing tank at Marintech confirmed that we were able to control the foil by means of actuators placed in the tow point of the foil. Our studies showed that we are able to generate energy with this concept, which means that further studies should be of interest.
Engervik Technologies and Coriolis plans to further examine this technology as it is feasible. More tests and analysis are required, but this might be one solution for future energy demands. Tidal power is constant, and we believe that Coriolis and the foil swing generator will harvest this energy in a nearby future.